Hello everyone. In this video, let's discuss about Opamp as integrator circuit, that is operational amplifiers as integrator circuit. If you are new to our channel, please subscribe for more engineering related topics. So in this operational amplifier as integrator circuit, here Opamp is used. In Opamp, minus terminal, that is negative terminal, and positive terminals, two terminals will be there. If you give the input to the negative terminal, so the negative terminal will be called as inverting terminal. It will amplify the input wave but in the opposite direction by providing 180-degree phase shift. If you give the input to the positive terminal, that is non-inverting terminal, it will just amplify the wave. Therefore, in this integrator circuit, we are giving the input to the negative terminal, that is inverting terminal. So we are using a resistance between Vin and negative terminal. Let's call it as resistor R1. So the voltage across the negative terminal, let's call it as VA, and voltage across the positive terminal, let's call it as VB. We also know that voltage across the positive terminal and voltage across the negative terminal will be equal to 0. Since the positive terminal VB is grounded, therefore the value of the VB will be equal to 0. VB equals to 0 as it is grounded. Since VA equal to VB, VA equal to VB equal to 0. So both their value will be equal to 0. In the feedback circuit, we are using a capacitor instead of a resistor. Let's call it as capacitor feedback CF. Now the current will flow from the input. So the current I will flow. The same current will flow through the feedback circuit also to the output. Therefore current is common. So we can use current as common in both input side equation and output side equation to produce an output voltage equation. Now at input side equation, so at an input side equation means Vin, that is input voltage to negative terminal voltage VA. So the current is common. I is equal to, we know the formula of Ohm's law. What Ohm's law says that? Ohm's law says that V is equal to IR. We need the formula of I, that is current. Therefore I is equal to V by R, voltage divided by resistance. What is the voltage in this input circuit, that is between Vin and VA? The current is moving from input voltage Vin towards VA. Therefore Vin minus VA divided by, what is the resistance? Resistance is R1. Therefore I is equal to Vin. What is the value of VA? VA value equal to VB. VB is grounded, therefore VB value equal to 0. Therefore VA value will be also 0. So Vin minus 0 divided by R1. Therefore what is left? I is equal to input voltage Vin divided by R1. Let's call this as equation number 1. Next, at output side. Output side means from negative terminal voltage VA towards the output voltage VO. So current is common. I is equal to, here there is no resistance, there is capacitance. So we must use differentiation. Therefore capacitance is CF, feedback capacitor CF into d by dt of voltage. What is the voltage? Voltage is VA and V0. Current is flowing from VA towards V0. Therefore VA minus V0. Therefore I is equal to CF into d by dt of, what is the value of VA? VA value is equal to 0 as it is equal to VB. VB is grounded. Therefore minus V0 is left. Minus is constant, take it aside. So minus CF d by dt of V output. Let's call this as equation number 2. Since in both input side equation and output side equation the current is same, that is left hand side is same, we can equate equation 1 and equation 2's right hand side. So therefore V in divided by R1, which is equal to minus CF into d by dt into V out. We just need the equation for the V out. Therefore let's integrate on both sides. Integrate on both sides. How you will know how to integrate? Because we are designing an integrator circuit. So just integrate. So when you integrate from 0 to t, V in divided by R1, which will be equal to CF is constant, minus, and capacitor feedback is constant. So minus CF integration from 0 to t d by dt of output voltage VO. So therefore the integration and differentiation will cancel out each other. Therefore what will be left? 0 to t V in divided by R1, which is equal to minus CF into V out. So we just need the equation for V out. So I will send the CF to left hand side. So this is in the numerator. When I send to the left hand side, it will become denominator. Therefore, and R1 is also constant, CF is also constant, which will be equal to minus 1 by R1 CF into integration of 0 to t V in by V in. R1 is constant, so we took outside, V in into dt. So I forgot to write dt right here. You write dt. Therefore the output voltage V out is the integration of input voltage. Output voltage is integration of input voltage, and the negative symbol shows that the input is given to negative terminal of the operational amplifier. Hope you understood the video. If you like the video, please subscribe. Thank you.